Welcome to Zion, Illinois, site of the now decommissioned Zion Nuclear Power Station, located on 257 acres adjacent to the shores of Lake Michigan, approximately 40 miles north of Chicago. The Zion Nuclear Power Station was a dual-reactor facility built and operated from 1968 to 1998, providing enough clean energy to power millions of homes and businesses in the Chicago metropolitan area. In February of 1998, Exelon made the difficult decision to permanently suspend operations for both reactors more than a decade ahead of when the plant license expired. After the shutdown, the facility remained in safe storage for 10 years until careful evaluations determined that early site decommissioning could be achieved safely and efficiently with current decommissioning funds. This idea to decommission ahead of schedule was a first-of-its-kind industry approach. The decision to decommission the facility ahead of its planned schedule was an aggressive approach which, when successful, would complete the decommissioning at least 15 years ahead of the proposed decommissioning timeline.
The Zion project was the first dual-unit large nuclear plant to be decommissioned in the U.S. And the industry needed validation that a company, and this was EnergySolutions with this one, could safely and compliantly decommission the plant within budget and schedule commitments.
This required transferring the spent nuclear fuel to an on-site interim storage location. Once all decommissioning activities were completed, Nuclear Regulatory Commission, or NRC, approval would be required to return the site to Exelon for the continued safe management of the spent nuclear fuel, which would remain on-site. With the approved license transfer, construction of the on-site independent spent fuel storage installation, ISFSI, or dry cask storage site, started immediately. It took 2 years to complete construction of the ISFSI before the first spent fuel canisters would be transferred. Transfer of the fuel from pool to pad was performed in 5 stages. First, spent fuel is loaded into an inspected and approved stainless steel container in the fuel pool. Second, further inspection of the steel container is performed to ensure the container has not been compromised. Third, the steel container receives one final inspection and is moved from its interim cooling water system and loaded into a reinforced concrete cask, which provides shielding and serves as its final heat removal system. Fourth, the final stage of fuel transfer is performed by transporting the 75-ton container to the ISFSI pad. The container travels at a whopping 2 miles per hour from the fuel pool to the ISFSI.
The spent fuel project here at Zion was a record, 61 canisters loaded in 366 days. It would have been 365, but on that particular day it was 30 degrees below zero and snowing, so we didn't think it was safe to actually move the last can to the pad. But overall, very impressive performance by the team.
And fifth, the spent fuel and greater than Class C containers located on the ISFSI are protected, monitored, and surveyed on a continual basis until turnover to the U.S. Department of Energy for final disposition in the future. A total of 61 spent fuel and 4 greater than Class C NRC licensed and approved NAC dry cask canisters were safely relocated from the fuel pool to pad in a record 366 days. The next step in decommissioning the facility was the removal of the reactor vessel's internal components, the reactor vessel and other large components. An estimated 40 vessels and segmentation pieces were removed and shipped for disposal. Once the large components and irradiated hardware associated with the large components were removed, major demolition began. Every effort was made during demolition to recover as much recyclable metal as possible. Vendors were hired to retrieve copper, aluminum, and high-grade steel for recycling.
Whether it's clean metal, for reuse and recycling in the industry, or whether it's contaminated metal that we process in metal melt through our Bear Creek facility and use as shield blocks in the nuclear industry, the main purpose here is to make sure that we reprocess in an environmentally friendly way.
The most visible deconstruction activity during the decommissioning project was the demolition of the reactor containment. These were the iconic, twin, giant cylindrical structures that once stood approximately 200 feet above ground level. Residents, visitors, pilots, and boaters alike hailed these as among the tallest structures in Lake County, Illinois. The demolition of these structures was a highly technical process that demanded engineers and heavy machine operators plan, then execute their work with precision and care. Once the demolition of the containment structures was safely executed, preparations were made for final status survey reports. When the final paper was submitted, it took nearly a year-long review by the NRC for permission to return all licenses and property back to Exelon Generation.
As we come to the end of the project, Exelon is pleased with the outcome of the endeavor. We accomplished our goal. Zion is now a greenfield site. We've proven to the industry that the asset transfer model worked and that the outcome was productive for both Exelon and EnergySolutions.
It's a validation to the industry that these large nuclear plants can be safely and compliantly decommissioned within a framework of budget and schedule. It also is like the reference plan for EnergySolutions for any other decommissionings we do in the industry, both from an estimate and a schedule perspective. We utilize the design project for our training grounds for our people. We have a lot of lessons learned. We didn't do everything right, but we tried to be open and honest about what we could do better next time. And that's part of our training basis for all our future project managers and engineers.